This LeetCode question is called Final Prices with a Special Discount in a Shop. So we are given an integer array called prices, where the ith element of prices is the price of the ith item in a shop. So there is a special discount for items in the shop. So if you buy the ith item, then you will receive a discount equivalent to the jth element of prices, where j is the minimum index such that j is greater than I, and the prices of the jth item is less than or equal to the price of the ith item. Otherwise, you will not receive any discount at all. So we want to return an integer array called answer, where the ith element of answer is the final price that we will pay for the ith item of the shop, considering this special discount. So here's an example of some input that we could get, the prices array. So a brute force approach that you may have already thought of is to just iterate through each element once, and just for each element checking the subsequent elements to see if they're less than or equal to the current element, and if they are, just minusing the subsequent element from the current element, and that giving you a new array. Now that does give us a correct solution, a correct answer. The only problem is it's a bit inefficient. We're iterating over the same prices multiple times, and the time complexity of this approach actually altogether is unfortunately big O of n squared, which, I mean, for this question, this problem is accepted by LeetCode. However, it's not quite the optimal solution that you should be happy with. So there's actually a solution which works with a time complexity of big O of n, so a linear time solution that actually uses a stack to efficiently find discounts and apply them to each element. So this stack is just a stack of indices of items which are possible candidates for receiving a discount from subsequent items. So all we do is we just want to iterate over prices, and for each price encountered during the iteration, all we want to do is check if there are any previously encountered prices in this stack here that could possibly qualify for a discount. All it does is compare the current price, so the price we're currently iterating on, with the prices at the indices stored in the stack. So if a discount is found, as in if there's a price lower than the current price, we can apply the discount to the appropriate price, which all we do is just subtract the discount from the price in the list. And then after applying this discount, we just want to update the stack. So as the stack just contains indices of items which may qualify for a discount, if we've actually applied a discount to one of these items, we can just pop that one off the stack, as obviously it's no longer a candidate, as items can only be discounted once. In either case, if a discount was found or not with the current index, we also just want to push the current index onto the stack as well, as the price for the current index can also be eligible possibly for a discount using future items. So the algorithm continues this process until all prices have been considered, and so by the end of the iteration, each price in the list will either have received a discount or will remain unchanged if no discounts were possible for that item. And then all we want to do is just return that modified list of prices. So if we just go through this example step by step, I'll show you how this works in more detail. So I'll just write out the indices of each item just so it's a bit easier to follow. So we've got I equals 0, 1, 2, 3, and 4. So we just iterate over prices. We start with the 8 here. And what we want to do is check if this 8 can be used to perform a discount on any item that's contained within indices. So as we can see, however, indices is empty, so obviously this 8 cannot be used to discount any previous items. So what we do in this case is we just push the index of this current item onto the indices stack. So the current index we're on is 0, so we just want to push on that 0. So now we just want to move on to the next element, which is the element at index 1, where the price is 4. So now what we do is we just want to check the indices stack to see if there's any prices we may be able to discount using the current item. We see that there's a possible candidate for a discount, which is the item at index 0. So what we want to do is just check the top value in the indices stack, which is this 0 here, which is the 0th item of prices. So now we just want to check if the current element's price is less than or equal to the price of the top of the indices stacks that indexes price in the prices array, which in this case the index is 0, so the price is 8. So we're just checking is 4 less than or equal to 8. We see that it is. So what that means is we can actually perform a discount on the 0th item here. So all we do is we get the price at the 0th item and we just subtract the price of the current item's price, which is, so that would turn into 8 minus 4. And then once we've done that, as we've applied a discount to the 0th item in prices, that means we can also pop it off of indexes as it's no longer eligible for another discount. So we just pop that one off. So now after doing that, the item at the first index of prices is now a potential candidate for a discount down the line. So we just want to push the current index onto the indices stack. So that would just be to push that 1. Now we move on and we want to move on to the next element. So on I equals 2. So once again, we just want to check if there's anything in the indices stack, which means is there any element that we may be able to use the 6 on to perform a discount. We see that at the top of the stack is 1, which means the element at index 1 in prices is a possible candidate for a discount. So now what we want to do is just check if the price of the current element is less than or equal to the price of the item in the indices stack. So we want to check is the price 6 less than or equal to the price of the first indexed element in prices, which is 4. Unfortunately, it is not. So that means we cannot provide a discount using this value on the 4 value. So that means we don't touch the price of the first element in prices. We also leave that index in the indices stack as well. And so all we do is just push the current element index onto the indices stack as well. So we just add that 2 there. And now we just move on to the next element. So now for this element, when I equals 3, once again, we just want to check the indices stack. For any possible candidates for a discount, we just want to start at the top of the stack and work our way down if we can. So now we're checking the element at index 2 in the prices array. We just want to check, so if the price of the current element, which is 2, is less than the second index at prices, which is that 6. So we're just checking is 2 less than 6. Well, it is, which is good. So what we can do is actually minus the 2 from the 6. So that's just minusing the price of the current item with the price of the item at the top of the stack. So that 6 just becomes 6 minus 2. So after that, after we've applied a discount on the item where I equals 2, it's no longer eligible for another discount. So all we do is pop off that value from the stack. So we just pop off that 2. So now what we do is we just want to check the stack again if there's any more items where a discount may be applied. So now we just want to check if the current element 2 again is less than or equal to the price of the element at the top of indices. So the item where I equals 1, which the price is 4. We can see once again that is true. So what we can do is minus the 2 from that price as well. And then as we've applied a discount to that item, we can also pop it off the indices stack as well, as it's no longer eligible for any further discounts. After that, we can just push the index of the current element onto the stack as well, as it may be eligible for a discount down the line. So we just push on that through. So now we move on to the final item where I equals 4 and then price equals 3. Once again, we just check this indices stack to see if there's any element that may be available for a discount. We can see that there is at index 3. So we just want to check if the price of the current element is less than or equal to the price at that position. So we just check, is 3 less than or equal to the item at I equals 3's price, which is 2. Unfortunately, it's not, so we cannot apply a discount to the 2. So we don't pop that 3 off of the stack. And what we actually do, push the index of the current element onto the stack as well, as if this prices array was longer, if it was extended by a few elements, we could continue this process again, just in case 2 and 3 will be available for a further discount. Okay, so after that process, we'll have our final updated prices array, which I will just come down and make a final copy just so we can see what the final prices should be. So that 8 is minus 4, so it becomes a 4. The 4 is minus 2, so it becomes a 2. The 6 is minus 2, so it becomes a 4. And the 2 and the 3 remain untouched. So we will just return this array. This is the result. So let's just move on to LeetCode and I'll show you how we can code this solution up. So first what we want to do is just initialize our stack to keep track of indices of potential discounted prices. And we'll also just initialize a variable to keep track of the size of prices. So now what we want to do is just iterate over each element of prices. We then want to check the indices stack to see if there's any possible items that we can apply a discount to using the current element. And as we may be able to do this to multiple items, we'll use a while loop here, just so that we can continue performing discounts if we can. So it's while indices is not empty, and also it's while the price of the current element is less than or equal to the price at the top of the indices stack as well. So in the case that both of these conditions are true, that means we can perform a discount on the top element of the prices stack using the price of the current item. So that means what we want to do is just update the price of the item at the top of the stack in the prices vector. So we will just access that item and we will just minus the price of the current item that we're on. And then as we've performed a discount on that item at the top of prices, it's been processed, we can't do any more discounts on it, so we just pop it off the top of the stack. And what this while loop means is that after popping that item off of the stack, if the next item on top of the stack is also able to be discounted using the price of the current index, or the current item I should say, then we can do that again and as well. Anyway, after all items that can be discounted using the current item are, or if maybe the indices stack is empty, we just push onto the stack the index of the current item, as it may be available to be discounted down the line. And then all we do after that is just return our prices array. So to recap, we've just got our stack here. We just use this variable to help us iterate through prices. We just iterate through each element of prices. And for each element, if there's an element in the stack that is greater than or equal to the price of the current element, that means that we can use the current element to perform a discount on the item specified at the top of the indices stack. If we can do that, then we just perform that discount. We minus the value of the current item's price from the price of the item at the top of the index, and then this should say pop, and then we just pop off the top value from the indices stack as we have processed that item. And then after that, no matter if any discounts were applied or not, we also want to push the current index onto the stack as well, as it may be eligible for some further discounts down the line. And so after this whole iteration has been completed, then our prices array should all be updated, and all the prices that can be discounted will be discounted, and we should have our correct result. So if we just submit that, we can see how we did. We can see that this solution, unfortunately, it only beats 50% of users apparently. I suspect this is because the constraints of the inputs are quite low. The size is only between 1 and 500. So the asymptotic time complexity improvement may only be seen when the input values are a fair bit larger. However, it's still much better to provide this algorithm in an interview, as it's asymptotically much better than the brute force solution, and it's much more impressive. You can also talk about some memory trade-offs though. This solution uses big O of n space complexity just to use the stack. The brute force uses constant space, which you can discuss that in some cases may actually be beneficial and may be favorable, but it's always good to discuss the trade-offs with all your algorithms in an interview. I hope you enjoyed this video. If you did, be sure to leave a like and subscribe, and I'll be sure to continue making these. If you have any questions, feel free to leave them in the comments below, and I'll be sure to get back to you as soon as possible. Thank you for watching.